So, hello. Today we're going to solve a question. Uh, it uses analytic geometry with limits concept, which are important for the max. Okay, so I took it first just to show it from this book over here. Okay, it's pretty famous, calculus book. James Stewart. Okay. So from the second chapter. In the end of it. Okay, so I'm going to solve this question over here. Now it's written in Portuguese over here, so he's given you this parabola over here, which is x squared, and he's given you that imagine you have this line over here connecting from 0 to a point in this parabola. When this point over here, point B, is going to 0, what happens to this point over here? And this line over here is perpendicular to this line. It is perpendicular and it cuts it in the middle. Okay, so these are the informations. Later I'm going to solve this other, let me try to show this other question with some similar concept, question 10. Okay, with this one over here in another video. So let's solve first this question over here. Okay, let me put the book on. So we have over here our parabola x squared. Okay, so what is he telling you is that you will have a line over here, right? So this is the line. Now I'm going to call this point over here x of this is point P, right? So I'm going to call it xp, and this is fp. Okay, f of the point P. Now notice that f of the point P is equal to what? It is x squared, right? So it is xp squared. Okay, so this is the point. Now imagine that this line over here is perpendicular. This point over here, well, it doesn't seem so, but this doesn't need to be the same point as f of p. Okay, but this is the point important over here. Now this point is dividing our line in two equal lines, right? So what does this make of it? So this is half of this xp, right? So this is over here, it is xp divided by 2. Okay, now notice that I'm not giving it any number because we want a general form. Okay, so this is xp divided by 2. And what is this point over here? We can find it. Let's first make this line over here. This line over here, how is it? Its formula is a equals ax plus b, right? Because it's a line, so it is this type of a formula. But what information do we have? We know that this line passes through 0 and 0 because it passes through this point, and it passes through, this is the origin. Okay, so the origin, and it passes through point P. Point P is xp and xp squared, right? Xp squared. So we know that it passes through these 2 points. Note that as I call this x xp, the y coordinates, as it's part of a parabola, it's xp squared. Okay, so first we can use the 0 0, so it is 0 in the y, ax, but x is 0 plus b, so b is equal to 0. Okay, now let's use the second information. Okay, so we'll have xp squared as our y is equal to what? Our a multiplied by our x. Okay, but remember our x is what? Is xp, right? Plus 0 because p is 0. So our a is equal to xp only, right? So we have this information over here. So our line will be in this form over here. Our line will be of the form of xp multiplied by some x over here. Okay, some x. Now the thing is, it depends on where the point P you want to choose. Our line is depending on that, okay? So this is our first equation, our equation for this line over here. Our A is xp, and then we can choose any x we want. When x is equal to xp, we'll have xp multiplied by xp, we'll have xp squared. Okay, so this is our first formula that we need to save over here. Now, to find this formula of this line over here, of this line, why is it changing the of this line over here? Okay, we need to remember from analytic geometry that when we have the linear coefficient of a perpendicular line, if you have this line over here, let's say like this, we have this line and this line, something like this, okay, and they are perpendicular, okay? So the linear coefficient, like if this is m and this is m comma, then you have that m multiplied by m comma is equal to -1. So the linear coefficient of this perpendicular line, this a of it, m comma, is equal to -1 divided by m, okay? You need to remember this from analytic geometry. Okay, so notice that our line, its linear coefficient is xp. So this one would be what? This linear coefficient will be -1 divided by xp. Okay, if you don't know this, go back to a linear analytic geometry book. Okay, what else do we know about this point over here? We know this point over here, right over here, right? Because this point is part of this line over here. So it is part of this formula, all right? So we can find its y coordinates like this. Look, y is equal to xp multiplied by the x, right? By the x coordinates. But here our x coordinate is what? It is xp divided by 2. So our y coordinate is it's xp squared divided by 2. Okay, so now we have this second point over here. I don't know why changing the luminosity. Okay, so we have the linear coefficient and we have a point that is part of this line. So remember, the x, it was xp divided by 2. It's not divided by, it is divided by 2 actually. Okay, it is xp divided by 2. Why? Because we are taking half of this. Now notice over here we are taking half of this 2, okay? But notice that you can't just say it is xp over here, okay? It is the xp squared divided by 2, okay? You can't take this over here, okay? You can't take it on the parabola, okay? You can't say it is divided by 4 because divided by 4 would be over here. So xp squared divided by 2, okay? What I'm saying is that you can't say it is this point and the parabola, so I'm going to put xp divided by 2 over here, okay? Because it's not the point on the parabola, it's the point on the line, okay? So this point over here, k over here, is part of our line, of both our lines actually, right? It's part of both our lines. So now we have the linear coefficient and this. So what can we do? Well, use the formula, right? Y is equal to x plus b, the formula for a line. So what do we do after this? Well, our y coordinates is xp squared divided by 2, which is equal to our a. But our a is -1 divided by xp multiplied by some x. But this some x, it is this x over here, right? So I should change it. So xp squared divided by 2 is equal to -1 divided by xp multiplied by some x. It could be any x, but as we are using this y coordinates over here, its x is this one, okay? So it is xp divided by 2 plus b now, okay? Remember that this is another line, so b is not 0. This line has a 0 at b, but this one doesn't, okay? So how do we proceed on this? Okay, so we'll have that b is equal to xp squared divided by 2 plus, well, xp divided by xp doesn't change anything, minus 1/2 goes to the other side, plus half, right? So we'll have that b is equal to minus xp squared plus 1. Okay, so now we have our second line ready. So y is equal to minus 1 divided by xp, because remember this was our linear coefficient, because our linear coefficient for the first one is xp, so it is perpendicular, multiplied by what? Multiplied by x. It can be any x, okay? I'm doing this, it's like, it's not the floor function, okay? I'm just so that you know that this is any x, plus b. b is 1/2 multiplied by xp squared plus 1. So notice, what is this telling us? Okay, because the question already ended, okay? So this is our second function. This is the function of this line over here, of the line perpendicular to this, from 0 to p, okay? It is a line perpendicular to this. Why is it perpendicular? Because we put this condition over here. So this condition makes it perpendicular. Now, how do we know it is it passes through the median point of AP as the question told us? Because we made this second condition over here, using this point that passes through the median. Using these 2 points as these 2 information, as it is perpendicular and it passes through the median point of this line, we made a line. We made this equation. So this is the equation that he is asking us, okay? So notice that if you remember from the linear equations that you learned, that the point where it cuts the y-axis is the b, right? It is the b. So you can do it by 2 ways over here. To finish the question, you can do it in 2 ways. One of them is, well, if I want the b, where does p tends when, what is the question asking? When x of p is going to 0, right? Because this point over here, it's closing. What is it happening to this point over here? This point where it's cutting, okay? So when x of p is going to 0, this point is what determines your y direction. So you are like choosing the limit when x of p going to 0 of 1/2 xp squared plus 1, right? So if xp goes to 0, then this goes to 0, then you'll only have a half, okay? And this is your answer. You can also say it is the limit when x is going to 0 and x of p is going to 0 of this y function over here, okay? Minus 1x of p x. When everything is going to 0, you are only having a half left. So, but I think that this is better, okay? This is our question. It has this parabola, orange parabola, it is x squared. We have this blue line that goes to point 0 and 0 and to a point in the parabola, okay? It can be any point. In this example it is 2 and 4, right? Because 2 squared is 4. Now the important thing is this green line, it cuts this part over here in half. It bisects it and it is perpendicular and goes through this point A. So these are the formulas. Look, the orange is the x squared, is the parabola, and then we have some values to A. We can change A. You can see how it changes, but you can see that the green line is always in the middle. of the blue line, right? So the blue line is ax, and then we have this green line, and all this I will show in when we are doing the math. The only thing is that I'm calling it xp when we did the math, okay? So notice that this point a over here, this point is the important thing. Now it is 0 in the x, well, because I don't want any axis, so it is 0 over here. And in the y, notice that it is the same as this green function b, the b of this green function, well, because it must be, because it's where it cuts, right? So notice what I need to know. Notice what happens, this value over here of a, okay? Now it is 0 point, it's 2.5. So notice how it variates. What it does it tries to be when a goes to 0? Look, 0.5, and then it starts jumping up again, right? Look over here, you see the green line always in the middle, so it's starting to go up, go up, go up, go up. Try to compute these functions first before watching me do it, okay? So now it's going down, because this is the point that's going down. As this point approaches 0, where this point approaches, it's approaching 0.5. Very interesting, right? Okay, you see, it doesn't approach 0 as you might expect it to be.